Welcome back. Our next speaker is Ed Oberg, who is going to talk about the 18.6-year lunar nodal cycle and the effects it has. We've gone from the very longest cycles to the very shortest. Now we're coming back to something that's in more human terms. Ed was born in the US in 1943, and he graduated from the University of Minnesota, where he received a Bachelor of Mechanical Engineering and Industrial Engineering. He has had an eclectic career as a professional engineer and project manager at Honeywell and Control Data in the US and other private companies, and the National Occupation Health and Safety Commission in Australia. He immigrated to Australia in 1969 and has lived there since. In 1974, he developed a special interest in celestial mechanics, which led him to undertake research work in the area of gravitational anomalies. His work resulted in the development of the Iasoberg model, which is what he's going to talk about with us now. It's all yours, Ed.
Thank you, Ray. Okay, now what do I do? Go to full screen or? Okay. All right, there we go. Okay, good morning. I've got to actually do one thing. I want to go to the full screen here first. Pardon me. And I've got a goodbye, Ray. I'm going to get going now. Pointer options. Oh, visible. Okay, good. Well, good morning, good morning, good morning. I'm going to talk about the 18.61-year nodal cycle and long-range weather forecasting. First of all, I want to thank cycles.org for having me on. Second of all, Ray for inviting me. Third, want to acknowledge the Darwall people. They are the custodians of the land where I'm giving this presentation from, which is about 60 kilometers south of Sydney. And I want to pass on a good day from down under to all of you good folk around the world. So here we go. I want to talk about the findings first that we found linking the 18.61 nodal cycle, the Iasoberg model, and severe weather in the USA. We found highly significant correlations over a period of 70 years with the elements of the model, the Iasoberg model, which is coined by myself, Iasobergs, and also it's trademarked, and the 18.61 nodal cycle. These correlations were found between the output of the model in conjunction with ranges of obliquity of the lunar orbit. And obliquity is astro jargon for the angle between two planes, where one of the planes is a reference plane. So the obliquity is an angle between two planes, and the plane that we're interested in today is the lunar plane, the orbit of the lunar plane, and the daily tornado, hail, and damaging wind reports in the continental USA from 1950 to 2020. One of the major findings was an extremely significant p-value, which resulted from a chi-squared analysis of the correlation, not the prediction, but the correlation between the output of the model and nodal cycle and the damaging wind day reports in a current 20-year homogeneous data set from the Severe Weather Prediction Center in the USA. The Iasoberg model is an exploratory celestial model developed to define a celestial influence that may cause the Allais effect, and we'll be talking about that a bit later. Okay. Here's what we're going to talk about today. We're going to describe the nodal cycle with a bit of verbiage and some images, some historical observations of the nodal cycle, the nodal cycle research and studies, describe the elements of the Iasoberg model used in the studies. We will be talking about the longitudinal studies of the celestial model and the nodal cycle and the severe weather events in the USA. We'll be talking about tornadoes, tornado outbreak days, hail event days, and damaging wind event days. We're going to have a summary and conclusion at where to next for this research and technology. And we're going to invite cycle.org members and seminar participants to work with us. Whoops. Here's the nodal cycle. Okay, don't get too bamboozled by this now. Here we have the obliquity at 23.3 degrees. The nodal cycle, or the plane of the moon, oscillates back and forth over this ecliptic by 5 degrees. And as it does, as the longitude of the node, or the intersection of these two planes, transgresses in a retrograde motion across the ecliptic, it actually defines what the angle of the plane is with respect to the ecliptic, and in this case, the equator. Here's a graphic of the, here is a diagram of the graphic. So we have the lunar plane here, which is 5 degrees below the ecliptic, which is at 28 degrees, which was the peak of the previous diagram. And as it goes through 180 degrees, it gets up to above the ecliptic, 5 degrees, and it'd be at 18. There's 2 points in the cycle where it actually, the circle would be like this. And if you put too many circles in there, it gets a bit confusing. But it would be at the same declination of 23 degrees as the ecliptic. Here is another example of some of the research we did and the implications, or some, what I'm trying to say, other information about the nodal cycle. Here are the 9+ magnitude earthquakes in the last 300 years. Here is where the lunar plane was, or the node was, when these events occurred. Looks like a bit of a pattern there. This one here was the Juan de Fuja quake in the Pacific Northwest. That happened on January 27th in 1700. And that was deduced from the indigenous people folktales and the history of the Japanese prefectures, which had an orphan tsunami. And they didn't know how it happened because there wasn't an earthquake, but it was from Washington, and they pieced it all together, and they found out the time that it happened. Here's the 1960 earthquake, the largest recorded earthquake in history in Chile, a 9.5 quake. Here is the nodal cycle that we'll be looking at with tornado outbreak days. Here are the regions where we found the strong correlations for the severe weather in the continental United States. And that'll become more clear as I go through the presentation. I want to put some historical observations to you. Well, one of the things I was just thinking about this morning is that apparently Scotland has got the highest number of per capita Nobel Prize winners, or that was what I read a long time ago. Maybe that's still not the case. But the first permanent artifacts that were made that marked the celestial heavens on the earth or on the ground were the hunter-gatherers in Scotland, 8,000 BCE, the oldest known artifacts. And apparently the archaeologists have said that they used those pits to identify when they should be hunting and gathering their food, and they used them to do it more efficiently. The Stonehenge, 3000 BCE, has 2 lunar standstill points outside of the main construction there, and they've been surveyed, and they are the standstill points for the maximum and minimum of the lunar cycle. The Egyptians, Indians, and Chinese were aware of and employed the nodal cycle circa 3000 BCE. And the Chinese, I've read, have used it to predict eclipses, not always successfully. In 1400 CE, the Mughals constructed a sophisticated observatory, Jantar Mantra, in Jaipur, India, I visited it. It's an interesting place. It's on about 2 acres, and it's constructed of stone and bronze, big features where they did line of sight observation of the heavens, and they published the ephemerides each year or for a period of time, which were very accurate and were used by the European sailors and navigators. That's just a little bit of history associated with that. I tried to find a link to a very suitable site about the nodal cycle. I couldn't find one that I wanted to recommend. They were over jargonized or they were too motherhood statements. But what I did find was 13 million links on Google search for nodal cycle studies and research. I also knew, but found out that there was a substantial amount of information about the Southern Oscillation Index tied to the nodal cycle. The nodal cycle also is linked to the North Atlantic Decadal Oscillation. A medical practitioner that I'm working with respect to the Iasoberg model, said make sure you put in there that there's a lot of evidence for lunar influences on terrestrial organisms, which in regard to the statement here. Oh, so we're going to talk about the Iasoberg model now. This is very interesting. This is where it kind of all started. Five microgals. Oh, I got to get rid of that. How does that happen? Oh, that's no good. Oh, there it goes. Okay. 5 microgals change in the gravitational field. Well, a microgal is 1 centimeter per second squared. 5 millionths of that was observed here and here. This is an experiment in 1954 with the isotropic pendulum swinging away, following the Foucault pendulum line. During the eclipse, it actually went off that line by about 13 degrees. Here is an experiment in 1997 in Moho, China, at the March 7th eclipse. For about 30 minutes, a data logger, 300 minutes, a data logger took 2,500 measurements and recorded them. And the net effect was a change of about 5 to 7 microgals of gravity. So if you stood under the eclipse and you weighed 100 kilograms through no fault of your own or Jenny Craig, you would end up losing 1 gram. So the Iasoberg model is an exploratory model developed to investigate the possible causes of the LA effect. I'll leave you to ponder Max Planck's statement about things that don't match up with the current theory. So we're going to talk about the Iasoberg model. When I was thinking about this, I thought, how does all this happen? I'm an engineer. So I started thinking about it has to probably be around the balance point of the Earth system, which is the barycenter, which is inside the Earth because of the relative masses of the Moon and the Earth. It's about 3/4 of the way to the surface of the Earth along the axis of the Earth and Moon. So the Iasoberg model has the barycenter, the anti-barycenter, and the center of the Earth as the focus of the influence or force of interest. So how do we get something happening in the region of the barycenter inside the Earth on the surface of the Earth to affect this instrumentation? Well, here's what I came up with. The model hypothesizes that the solar and galactic gravitational potentials near these points are distorted in the region of these points, and these potentials, gravitational potentials, and their resultant distorted gravitational vectors, which is a result of field theory, extend to the surface of the Earth. Now that'll be shown graphically in not this slide, but the following slide. So we want you to conceive of 2 sets of 3 planes. one set orthogonal to the Earth's solar axis, and the other set, similarly oriented to the Earth galactic center axis. The locations of the orthogonal planes along these axes are determined by the position of the barycenter, center of the Earth, and the anti-barycenter along the Earth-Moon axis. Now, if you have a plane orthogonal to a line, in order to fix it, all you need is one more point, and the barycenter points do that. The intersection of the solar and galactic sets of orthogonal planes with the surface of the Earth were calculated in geographical points of latitude and longitude and plotted accordingly in various mapping platforms and application. These celestial parameters are calculated from the input of the Julian dates or part thereof using simple spherical geometric formulae. It's all spherical geometry, no second order equations. So here's what it looks like, okay, in a rough sense. We have the Earth's solar axis. We have spheres of solar gravitational potential. We have our points, the barycenter. This is going through the Earth, by the way, okay? There's the polar axis and there's the equator. And we're saying that there's a disturbance here in the potentials, and they extend to the Earth, surface of the Earth. So the gravitational field isn't homogeneous in the darker areas here, dark dashed areas. That's what the essence of the model is and what we're going to be using as we work with the forecasting mechanism. Well, here's what it looks like on Google Earth. Here we have the green are the galactic envelopes. Behind it are the red solar envelopes. And they are along both of those axes to the sun and the center of the galaxy. They're not the same axes. It looks like this from this output. Both of them are near the solstice. The Iasoberg model program defines these Iasoberg envelopes as color-coded tagged longitude and latitude points. The program can be coded to accurately generate these points for any instant between 2500 BCE and 2500 CE. And the accuracy of some of the points that I'm dealing with respect to the sun and moon and that sort of stuff, using my coding is within 1/10 of a degree when compared to the Naval Observatory. Oops. Okay. Well, you've heard of Mercator projections. That's another form of mapping system. Here we have our planes. The green are the galaxy. The red are associated with the solar axes. Here is the barycenter slice going through the Earth on a Mercator projection. Along there would be the barycenter from the galaxy. Here's the one at the center of the Earth, and here's the anti-barycenter. Now this configuration happens, and we can generate this for any instant of time. Okay. So now we're going to talk about, now that we've got the tools, we've got the nodal cycle, we've got the elements, we're going to talk about the saga of finding the correlations among the elements of the Iasoberg model, ranges of the nodal cycle obliquities, and the reported severe weather events in the USA. Did I cover one thing here? Yes, I did. Okay. So here was the Iasoberg.com 18-year cycle studies, severe weather studies in the continental United States from 1950 to 2020, December 31st, which are up to date. We have now identified days because of the algorithms that we're using until 2030. We're going to talk about the tornado studies, tornado outbreak days with 20 or more events in the 24-hour period. And a 24-hour period is from 12 UT on the day to 11:59 the next day. That is the unit of measurement for our tornado events. We're going to talk about the analytical protocol and the statistical results. Work on the potential F5 tornado days is well advanced. We won't be discussing that today. A tornado study paper has been drafted and will be submitted for publication in 2021, and that will encompass most of the stuff that's in this presentation. The hail studies similarly looked at hail events of more than 60 hail events during the 24-hour period. We'll show those statistical results. Work on potential large hail days, 6 inches or more, 15-centimeter events, is in the initial stages. Damaging wind studies, which will show the statistical results, also of 100 more events in a day, and work on derecho wind events is also in initial stages. And that's where a band of wind heads across the continental United States over a period of 7 hours. And it's sort of like a vertical, straight, destructive wind that occurs for that period. So, search for statistically significant geophysical phenomenon. Subsequent to the development of the model, various correlations were observed between the locations of the intersections of the planes and the sites of the sensitive gravitational apparatus during the eclipses. Well, they were so infrequent that you really couldn't actually start hanging your hat on a model that came near those sites once every 4 years or 5 years. Assuming the model had some merit, a search was undertaken to identify a geophysical phenomenon to build a case for the statistical verification of the model. That was my idea. The data set describing the above phenomenon had to span many years and have accurate data, time, location, and intensity if possible. From those studies, I found out 9+ magnitude earthquake nodal cycles, nodal points. After many preliminary investigations of geophysical phenomenon, which included what I just said, severe weather reports in the continental United States were identified and selected for further investigation. A study of severe wind reports for August lent more evidence to support the model, but found no significant statistical results. But what we did find was one thing in that study. We were then projecting the Mercator projections, the output of the model on Mercator projections for those various times during that study. We also were superimposing on a 24-hour basis across the 360 degrees of longitude, the severe weather events at a latitude for a particular day. Well, on a number of occasions during that month, we noticed that there was a large number of severe activity when the bands or the envelopes were in a particular configuration, i.e. here. They were all on one side of the pole, the North Pole. Well, here we go. Now we're showing them on Google Earth. We have the 3 bands here. We know what day it is. We can actually know what time it is. We have another set of 3 bands here. The pole is on one side of the bands are on one side of the pole here, and here the pole is inscribed by the bands. So those were 2 conditions of interest that we were going to follow up. And what we did in 2008 in December, we kind of had a better feel for what we were doing. So what we did is we started identifying the days when in regard to both of the axes where the envelopes were on one side of the pole. And that sort of set up a window, as it were, of when they were there. So when all 3 were on one side, we started counting the days and increased the count until one of the bands went back on the other side of the pole. When that happened, we maintained the count at a constant rate. And we then increased the count here for the next series of days where that occurred. And similarly for the galactic axes. For the solar axes, these windows vary from 6 to 1 day, and the 1 day is typically around the equinox. And I can tell you about the geometry about that. It's a little complicated right now, but I want to move on from there. And for the galaxy or the galactic axes, 6 to 7 days. Now here was the rationale. We wanted to use hail and hail reports because of the hard evidence of the hailstones on the ground, time and location. 75 hail reports of 3/4 inch during a 24-hour period were used as the hail criteria. The number of 75 hail reports per day was suggested by the ex-chief of operations then at the National Oceanic Atmospheric Administration. Boy, these things are tongue twisters. At the Severe Weather Prediction Center in Norman, Oklahoma. So we did that in December. It's just an idea. All we had to do was wait 365 days to see what happened. Well, this was a surprise. Our humble little Iasoberg model picked out or identified the days where the 3 largest hail event days occurred in 2009. That year was a bit unusual. There were 46 75 hail event days. The model identified 29 of them. If you use these groups of 140 days identified and 365 in a year and put them in a 2x2 contingency calculator, we ended up with a p-value of 0.0005. Well, when you do something like that and you get an initial result like that, you think, oh, the rest is going to be easy. Well, as you know, science doesn't work that way. 2009 hail forecast results could not be repeated with the Iasoberg algorithm. The 2010 analysis between the model and the forecast and the hail reports did not show similar correlation. A hindcast from 1980 to 2010 for the hail correlations showed sporadic correlation. Tornado and damaging wind hindcast analysis showed a similar non-correlative results. Consecutive years in some instances showed strong correlation with the forecast and no correlation in the next. That was hard to understand how you could have that result in 2009 and nothing in 2010. 2011 to 2016, the forecast reports show the same pattern. Okay, back to the drawing board. Analysis of the 1950 to the 2016 correlations of tornado reports suggested a 19-year cycle, which led to the introduction of the 18.6-year one cycle in conjunction with the output of the Iasoberg model algorithms. Finding this stuff isn't simple. So what we then did is we start looking at all aspects of this cycle, and we started using various longitudes or latitudes of the lunar plane or longitudes of the node in conjunction with the output of the model, and the p-values started going down consistently when we applied it across a hindcast of 40 years. Here is the numerical table of the areas of the cycle that we were using for testing the correlations. These are the ranges of degrees of obliquity of the lunar orbit. So here's how we do it. Here are the herbs and spices. Okay, so as I've said to you, we have now, here's 2023. This is all, the days are all identified. But here's typically how it happens for the days where we have had reports to test against. This is for tornadoes, tornado outbreak days. So we have our windows. We have observed that we see more tornado activity at the top day of the window and the bottom day of the window, and the day adjacent to the top of the window and adjacent to the bottom of the window. And this applies for the galactic axis also. Here is our lunar range of obliquity that we're using. Excuse me. So we can count these. This is quite easy to record, to identify. When we have two greens, that is a day that is identified as a potential tornado, 20 event tornado outbreak day. This same protocol applies for the hail, as you would have seen previously, and for damaging wind days. So what happens now is when you put this in a spreadsheet and then you put all the 20 events days in there, you can actually do some very interesting analysis. And here's what the correlation ended up with. We have 25,933 days in the study period. 630 20-event tornado outbreak days occurred. We have 15,980 nodal filtered days, on which 427 20 tornado outbreak days occurred. We have 7,615 days identified by the Iasoberg algorithm as potential tornado outbreak days. A chi-squared calculation based on the 20 event days and 25 tornado outbreak days. And we use those two values. I put them in there because I wanted to see if there was any difference in the correlation with respect to more intense activity, i.e. 20 tornado outbreak days opposed to 20. And the results, when you look at the days where the algorithm identified the tornado outbreak days, was 0.0035. It's a correlation. It wasn't a prediction. It correlated in that to that value of that p-value. 156 out of the 277 25 event tornado outbreak days. 230 of the 427 20 outbreak days. 20 tornado outbreak days, which included 25 TODs. So that was a pretty significant result for the tornado reports. Here's some anecdotal evidence from the forecast or the mechanism used to identify the tornado outbreak days. This is very, very interesting, the next three slides. So we generated this in 2016 in December. There's no way any computer, no matter how big it is, Big Blue, can advance a forecast more than 4 or 5 days for severe weather. It's impossible. Nobody can do it. But our model, as you know, we're headed out into 2030. We could extend it to 2100 if we wanted to. So this is the forecast, or the days identified in 2017. You can see here, it's early January. We've got the 2nd and 3rd of January, 7th and 8th, the 31st and 1st of January, and the 6th and 7th. Well, they do some work there. Their taxes at work. They have, for all sorts of severe weather, they have what you would call probabilities and regional forecasts for each day in the continental United States. And this is based on a data set from 1982 to 2001. So let's just refresh our memories. Here we have a day identified as a potential tornado outbreak day. Here, if there is going to be a tornado outbreak, is where it's going to happen. And what happened on January 2nd, 2017? Now that is impressive. I must say that surprised me when I had a look at our model and the forecast from NOAA. So that's something to think about. I'm going to briefly cover these. So here's the correlation results from our hail event studies, were 60 event hail days and 90 event hail days. We had a very low, very strong correlation here, a p-value of 0.0181. This was probably a null result for the 60 events. Here is the wind studies from 1970 to 2020. Again, we had 128 out of the 227, 150 event damaging wind days, resulting in a p-value of 0.069. It's interesting that p-values for the higher intensities are all in this around the same magnitude of p-values. 100 event damaging wind days resulted in the 0.047 p-value. This is probably the most interesting finding or major finding of the work. Before 2000, the data sets that were provided by NOAA were kind of ad hoc. At sometimes one officer would put the data in one way. The reporting probably wasn't consistent, or the criteria for a report wasn't. In 2007, they set up a protocol where they have a consistent reporting regime. So we now have a damaging wind data set from 2000 to 2020, which is current and homogeneous. And when we applied the protocol to that data set, which is very good data set, we ended up with a p-value of 0.0012 for the correlation of 150 event damaging wind days during the respective periods of the protocol, and 0.0068 for the 100 event damaging wind days. That's very important. That's very important. Well, that happened quite quickly. I'm not quite so nervous anymore. I did get everything across kind of the way I wanted to. Just a few more slides to go. We now can see that there are correlations, not predictions, associated with some astronomical parameters that we can define. The galaxy and the Earth-Moon system, and the sun and the Earth-Moon system. We have shown significant statistical correlations have been demonstrated with the output of the model and the 18-year cycle ranges of obliquity, and the NOAA reports of all types of severe weather activity, which includes tornadoes, hail, and damaging wind. My belief that the model provides for long-range forecast potential for TODs, F5 tornado days, hail event days, potential large hail days, damaging wind days, and possible derecho events. That's a severe wind. The output of the model, in conjunction with the NOAA SPC weather data sets, provides a useful tool for identifying the timing and location of potential future severe weather events in the continental United States. Here's an important thing to keep in mind with respect to this work. Should a physical influence be the cause of these correlations, it is undefined by our current state of knowledge. Where to from here? Oh, I'm going well. I've got my timer here. I'm pretty happy. We want to publish the tornado draft paper in 2021. Seek to have the studies findings repeated and verified by relevant experts. Evaluate the studies with the view to use them for the purpose of long-range forecasting by relevant authorities and organization. This is important. You know, people in Iowa would like to know this at certain times, if we can make that of value to them. Continue the fundamental research based on the model with the view to finding and defining a seamless algorithmic interface between the current classical mechanical theory, which is the gravitational theory, and the elements of the model. We have one of the LA community, what I would say, not experts, but person who is not experienced, dabbling with adding a term to Newton's equation of gravity, m1 times m2 over r squared plus his term. That's what we're talking about. Some very, very fundamental understanding of gravity. Draft a document which would enable the licensing of the research and software associated with the Iasoberg model. Form a consortium to capitalize, manage, and progress the findings of this research to implement them into the global economic infrastructure. So here's the invitation to the members. And I really do thank you for the opportunity to present this information to you. Comment on the presentation and tornado paper in 2021, peer review or when published. Verify, validate, or repeat the studies. Provide assistance to progress the current research work forecasting severe weather. Participate in the continuing fundamental research. Become part of a consortium to investigate the commercialization of these findings. Thank you very much. My brother was part of the process in developing this material. Do I stop the share now? Okay, well, how did that go, Ray?
Thank you, Ed. I have a better understanding of what you've been doing now. I mean,
Right.
It's a long time since you first contacted me.
And,
right.
Part of your stuff is there, you know, and in the analysis, right?
Yeah, and you were the statistics you were asking about, I think. Anyway, it's very good to see that and get a much better idea of it. Several things have come to mind
Sure.
while you're doing that. One is I wanted to mention a little bit about LA gravity, because that is an accepted area. It's an area accepted by standard physics, that something's going on and they don't know what it is.
Correct. This is correct.
And so that's a very important one. So this is an area for possible breakthroughs into new physics, as you mentioned at the end there. I wanted to mention Sir Fred Hoyle in conjunction with Stonehenge. Someone went up to him once and said, an American's written a book saying Stonehenge is an eclipse computer, is that right? And he said, I shouldn't think so. And he said, well, you better write a book saying it's not. And he said, I'll have to study it first. So he studied it and wrote a book saying it is an eclipse computer.
It has been surveyed. Those 2 points for the standstill are outside of the Stonehenge. They're they're not the major thing, but when they surveyed the points, they are the maximum and minimum of the lunar cycle.
Yeah, and it's interesting because he goes on to analyze where the Greeks got their knowledge. We have what's the cycle called? The
nodal cycle? No,
the eclipse cycle. It's not Saros, one of those ones. Anyway, he had this cycle, and it's got a name from someone from those ancient times, and it was the ancient Greeks it's attributed to. And he went back and studied it and found, no, the ancient Greeks said they didn't invent it. They actually got it from the Minoans before them. And then they found out that, no, they actually got it from the ancient British. Well, they got it from a place that was, they said it was an island somewhere to the north, and they had built this big circular structure and worked it out. So that actually went down there and came back again.
We must have a propensity to do that. If you go to that Jantar Mantra thing in India, people have built these stone monuments pointing toward the sky. And how about those Scots in 8,000? You know, they're canny people. That's right. You know,
the British Isles were doing fantastic stuff way back then. Yeah. As were they in India and China, other place in Egypt. One thing that's occurred to me during this is your predictions. I think that one of the things the foundation should do is have a place where people who are making predictions about things can log those predictions. We have a secure site so that stuff that's put there can't be taken away, and it sits there. So in future, people can look back and say, yes, this person did do this, and they did discover this, and they did do analysis this way, and they did predict this, and this is what happened. So I think.
Oh well, as I said, for each of the years now, I update my studies every quarter. At the end of every quarter, they're updated.
But we need a site where we can say, yes, you did do that.
Sure.
And you didn't make that up. And it can apply to other things. It can apply to the stock market or any other area of science or anything that we could put that. So that's something I want the foundation to do.
Right.
So thank you very much for your talk, Ed. It's very interesting. It's not entirely easy to get your head around all these.
I'm cruising through it very quickly, and you can see that I wanted to cover all that stuff. I had to remember, this is like 34 years of work put into 45 minutes. So I had to pick various things, to highlight what's happening. But everything there is basically spherical geometry and the model, why that happens, I don't know. But when you get a correlation of 0.001, that's amazing. That's significant.
Yeah. So then someone's asked a question here. I'm not sure who this is aimed at, whether this came up before or now. Mike asks, how would you suggest we find more information on relationship between lunar cycles, phases, and the stock market? So it's a little bit like the question I got before. I don't know that there is a relationship between those and the stock market. Maybe there is between disasters.
Well, here's what I talk to people about when I talk about my work. Have I got a few more minutes to talk? You know what I mean?
Yeah, talk for a couple of minutes, yeah.
Yeah, right. Imagine Madame Curie, okay, when she sees her first X-ray of her hand, okay? And then she might have found some other things out where she could actually see inside the body, albeit very foggy, if you understand what I mean. And when she actually did that, or had looked at a series of X-rays as a radiologist, not a radiologist, but a radiographer person, she probably knew more about the body from looking at images than a doctor. She showed that to a doctor. It would be, do you understand what I mean? Very blurry and all that sort of stuff. But to her, because she'd seen many of them at the initial stages of the technology, she was more conversant with it. And the point I'm making here is, we're still going through the weeds with respect to this work that I'm doing, if you know what I'm getting at. Where eventually, maybe a meteorologist can start seeing things here and tease out more useful information when he knows what he's looking at. That's the point I'm making, is that when you do the initial spade work, you know the most, but after that, when the real people take over, they go way past you from the information that you've been provided, fundamental information you've provided.
Yeah, thanks, Ed. Actually, there was I just remembered a case from the foundation from many years ago where someone was comparing the 1929 share crash to the 1987 one. And they were looking at them, and they showed how a lot of similar things happened during that year. And they related to the phases of the moon. And eventually one guy got up and he says, I forget about you guys. He says, us Jews know that it's the same one because it is actually the same day of the month in our calendar. and so it's totally obvious that the lunar phase is important in all of this. So it's always good to know that. It's always good to keep track of the lunar calendar as well as the other. Now we've got another question. The sun's barycenter we know lies a little outside of the sun because of Jupiter. My question is, mass influence in conjunction with culmination aspects, do they impact the sun's barycenter? Actually, it doesn't lie outside because of Jupiter. It lies outside when Jupiter and Saturn and some
are on a certain side of the sun.
Are outside, so it moves in and out of the sun's surface. Yeah.
Right. These dynamics are associated with the Earth-Moon system. Okay. And to extend it to the galaxy, I just did that on spec, if you understand what I mean. And the F5 tornadoes, when we do an analysis with them, I didn't include them in here because I didn't want to take up too much time. That shows a very strong correlation with the F5 tornadoes and the galactic window. And again, if you hand that over to a statistician and he just does exactly the same thing that I've done, he'll get the same result. I'm not fudging numbers or anything like that. I'm just, you put it in a spreadsheet, add it all up, and it comes out like that.
Yeah. Now, Paul Leopold asks, is there a barycenter ephemeris like there is for geo and helio?
I've tried to find that. There is for the JPL laboratory has the barycenter for the solar system for 3,000 years BC. That's one I use in another analysis, but they don't have one for here.
I'm trying to think what website that's on. It's JPL, is it?
JPL, yeah. It's a Horizons. It's called Horizons.com.
Horizons, that's the one, yeah. Horizons.
Yeah, right.
Go to the Horizons website, Paul, and you'll find the information there. You can download
for the solar barycenter. For the solar barycenter.
Solar barycenter, that's right. Yeah.
For the Earth barycenter, you got to calculate it. You have to. It's not hard. You just generate your own program, and it'll print the barycenter. But the point is, go ahead.
Yeah, if you download the data for the position of the moon, the position of the Earth and the sun and so on, you can then calculate that relatively easy in a spreadsheet from those positions, because the lunar orbit is hard to calculate.
Right. I saw a question about the El Nino and El Nino. Of course, the Southern Oscillation Index is related to the lunar cycle, the 18.6 lunar cycle. There are papers that discuss that. So the Southern Oscillation Index is the El Nino or El Nina.
Yeah, because the Southern Oscillation Index is one of the harder things to predict. We know when we're up there, we're going to go down sometime soon in the next few years, but the timing of that, you can't, predicting a long way ahead. I've spent some time looking at that, and it's not easy.
No, well, I think it has to do partly with these ranges of obliquity plus another factor. You know, just like I tried to, from the hail, the 2009 hail, I thought we were home free. Another 8 years later, you know, we're still stumbling around in the dark.
Yes. Okay, well, thanks very much, Ed. That was that's good. And this whole 18.6 year thing is one that has kept coming up in the foundation, and I'm sure it will some more.
Okay, well, thank you very much for the opportunity, Ray. I hope I've provided some insight into that. And I've left the information how to get in contact with me if anyone's interested in following up with any questions.
Yeah. So Charles has asked, is there a correlation with El Nino, La Nina? Well, you're saying that yes,
of course,
that is a Southern Oscillation Index, so there is a correlation.
Right.
Yeah, and many people are thanking us for another amazing presentation. Mention, if you like this content, consider joining the FSC. Well, you're asking people to help you with these things, do this. So there's an opportunity. People can join the Foundation for the Study of Cycles. It's only $99 a year, and you get a chance to join in and help with all these projects. I think there's some.
Well, that's one thing I will do. The other thing is, but if anyone wants to contact me, they're more than happy to do that. You know, the invitation is to the members individually or collectively, whatever. Okay.
Yeah. I suggest people do this through the YouTube videos, comments. You put comments on YouTube, and discussions can ensue there. Questions and further answers can be done there.
Okay. All right.
Very good.